you guys back up on my other screen so I can see everybody. All right, there we go. Okay, so what we are talking about today, lesson 3.3, is actually one of the good ways that statisticians use to take samples. It's called a simple random sample, abbreviated with an SRS. Last lesson, we talked about some bad ways that people take samples. We talked about the convenience method of sampling, and we talked about the voluntary method of sampling. We talked about how those are biased. And so today we're going to talk about a good way, something called the simple random sample. It's the most common way that statisticians use to take samples. So that is going to be learning target number 1. How do we do this? There's going to be 2 ways that we talk about doing it. And then the second thing we're going to talk about is this idea of what's called sampling variability. And what happens when you take, instead of a sample of 20 centennial students, what happens if I take samples of 50 centennial students? What happens as I increase the sample size? And we're going to try and see visually, hopefully pretty clearly, what happens when we do that. So we're going to do our activity, Gettysburg Address Part 2. We're going to look at a couple examples of that, and then we'll kind of wrap up by showing you what it is you need to work on for today and tomorrow. Rachel, are you going to make it? Okay. You look like you were nearly out of it right there. Okay. All right. Here comes Eli. Okay. So here's what we're going to do to start off with. You might remember the last time we met, you guys picked a sample of 5 words from the Gettysburg Address. And the first way you did it was you picked them just out of your head. You just said, oh, I'll choose this one, this one, this one. And the second way you did it was a random sample. And what I want you guys to do, problem number 1 on this worksheet, I want you to make a quick copy of this dot plot. This is the final results. This includes you guys, first period and 5th period. So you didn't see this last time we met. This has everybody in it. But this is the dot plot. Every single dot on here is one of you and the other students. And this, every single dot represents the sample that a student took. They found 5 words, and they found the average number of letters in their 5 words. And so we're plotting these averages. So as you rough sketch this out, again, don't worry about counting exact numbers of dots or anything. The key thing to look at is that I do have the blue line of ultimate truth sitting right there at 4.26. That blue line represents the actual average of the entire population. Every single word in the Gettysburg Address, when we put them all together, has an average of 4.26. Some things I notice here, remember how we talked about how this looks like this was an unbiased method, because about half of our samples are lower than that blue truth line, and about half of our samples are higher than that blue truth line. That's what unbiased means, is about half the time you get lower, about half the time you get higher than the truth. A couple other things I just noticed that look a little odd. We did have a couple people out here that got some pretty high averages, around 7 and 8 out there. That's kind of surprising to me. I would wonder if that was, if it was really done randomly or not, but you know, you never know with random, that could happen. So that's what happened when we took samples of 5 words at a time. Okay, so keep this in your mind. You got it on your paper. We're going to see how things change here in a little bit. Okay. All right, everybody got it in there? We're good to go. You got a rough picture. Rough picture is the name of the game. You don't need to have every single dot perfectly marked in there. Okay, here's what we're going to be looking at then. Idea number 1, this is big idea number 1, is we're going to talk about 2 different ways that you can take what is called a simple random sample. How do you get a simple random sample? So you guys have already done this, actually. When you did this on the computer the other day, without knowing this word or this term, a simple random sample, this is what you were doing. So we're going to talk about, make sure we know real clearly, how do you use that random number generator to get a simple random sample. We're going to try and be kind of detailed, so we don't just say, hey, just do it randomly from Google. Okay, we got to be a little more specific than that. So I'm going to go out here to some Jamboard notes so I can kind of type this up. I have found writing with the little pen does not work very well, so I'm going to just use a little text box and type this in. So how do we do this? How do we kind of describe and give detail to how we found our samples of 5 words using that Google random number generator? So here's what we did. To start off, and so we're going to look at 2 methods. You're going to want to have these written down. These are part of our big idea. So find yourself a spot somewhere on your notes to write this. Here's basically what we have to do and what we did do. You have to give every word a number from 1 to 268. Now, I know there's 268 words, so that's my highest number. That's kind of like giving an ID number to every single word, just like how, every student has an ID number. Everybody with a driver's license has an ID number. We're giving every word an ID number, just starting from number 1 up to 268, the max number of words. So this just helps me to identify them. What do we do next? Next, we're going to use a random number generator. We've been using the Google one to do it, but there's lots of other ones out there. Use a random number generator to select 5 different words. And notice I put different in all capitals. If I could bold it and change it to a color to emphasize it, I would, but I can't do that on here. This is a key thing. You've got to make sure that you pick 5 different words. Just like when you roll dice in a game, you could roll a die and it could come up 5, 5, 5. It could get repeated numbers like that. Well, you could do these random numbers and get repeated numbers from the random number generator. But I don't want that. I don't want to have, like, if I go out to the random number generator and I set it to 268 max, and it gives me word 77, I could hit it a second time and word 77 could pop up again. Now, it's not likely to, and in fact, it didn't, but it could happen again. And I don't want to have the exact same word get repeated in my sample. So we got to make sure we have 5 different words. And then we're just going to do this. Use those 5 words as the sample. Okay. So every word gets a number. We use Google, some random number generator, to spit out 5 different numbers. And then that tells me what words to use. Okay. Pretty slick, pretty easy, pretty quick. That's what we did on our last class meeting. Okay. All right. That's one way, using technology. Here's a way that doesn't use technology. Believe it or not, we didn't always have random number generators just at the touch of a button on a website to us. So what statisticians used to do is something called the hat method. And they would literally use a hat to do this. So we're going to talk about how we could use this hat method to also get a random sample. So I'm going to go back here and describe how could we use the hat method. Well, here's what we could do. We're going to do this to start out with. I'm going to write every word on a slip of paper. Okay. Now, right away, if I was going to do that, you can tell this is going to take a while. To write 268 words on 268 slips of paper, it's going to take a while. Don't worry, we're not going to do it this way, but I just want you to understand this method. So I'm going to write every word on a slip of paper. I'm going to put all slips into a hat, and then I'm going to stir the hat really well. Okay. This is just like when you play a card game and you always shuffle the deck. And a lot of times you shuffle the deck more than once. You want to mix everything up. So we got to mix up all these slips of paper. The last thing you want to do is write all 268 out and then sort of just gently place them in the hat so they're all in order and just like take the top 5 out. Okay. Then it's not random. So we're putting all the slips in, we're stirring it up really well. And then what do? We select 5 slips of paper. Those 5 words are the sample. Sample, okay? Now, this time, I don't really have to worry about, did I get a repeated number? Because when you take the slip of paper out and you set it down on the table next to you, there's no way to pick that same word out of the hat again because it's been removed from the hat. So I don't really have to worry about, am I getting different slips of paper, as long as I leave the slip of paper out of that hat, okay? So questions on the methods. Do these 2 methods make sense to you? I know we did the Google number generator the other day, And now we're just kind of discussing the hat method. Does it make sense how we could set these things up? Questions with them? Remember, anytime you got a question, you can throw in the chat if you want to. I've already seen a couple things coming in the chat from you guys. I've got it up, so I'm watching it. Okay, then let's get into it. Here comes our big idea then for the day. I'm going to have you guys actually take another sample of words from the Gettysburg Address. And you're going to do it the very same way that you did it the last time. The difference is you're going to take 10 words now randomly out of the Gettysburg Address. Okay? So remember the process. If we're going to do this, and I come over here and it says word number 33 is my first word, I'm going to go to my sheet and I'm going to find word 33 is going to be on the line that starts with word 30. Equal would be 30. Now would be 31. We would be 32. The word are would be 33. I would have a 3-letter word right there. I would keep track of that. You guys are going to do this 10 times, 10 words. If you need a different color, because you got other words already marked, maybe use a different color, maybe box them off or circle them off so you know which ones are different. But take a couple minutes here. It's going to take you a little while. Get your 10 words, find the average number of letters in each word, and when you get that average, you can put it back into the chat, and we're going to see what happens here, okay? So take your time, be careful with it, and find your 10 words. But make sure we're doing it randomly. Trevor Higgins, hello. I don't think I said hi to you as you joined in. There he is. So we're going to see something. I hope we see this. We should see this. Something that should happen that's going to be different because you're taking samples of 10 words at a time instead of only 5 words at a time. Because we're going to make that dot plot here eventually. But take your time with it. Get your 10 words. Find the average. While you guys are doing that, has anybody been to the Lincoln Memorial out in Washington, D.C.? Anybody been there? Rachel's been there, she says. I went out there with my family a couple of years ago, I think. We were out there in the summer. And inside of the Lincoln Memorial, it's a huge, huge kind of stone building. Yeah, I'm sure you've all seen the big statue of Lincoln sitting in the chair there. But on one wall off to his side, this entire speech is carved into the wall. And it's massive. It's like 3 stories tall, and all of this, the entire speech is just carved into it. It's kind of cool to see it there. So as you get your average, when you find your average, you can round it off. Maybe give me at least 1 decimal point. And then you can put it in the chat. And as they start coming into the chat, we'll begin plotting them on that same website or that same software program we had. I can see a few of them starting to pop in there. Eli, I'm not sure about your number 0.7. That means the average word had less than 1 letter in it. I'm going to guess something's off there. So you might want to think about, maybe look back at what you did and see something there. Okay, I'm going to start. I see all your numbers starting to pop in. So here we go. I'm going to throw the charts back up there. Here are the dot plots we did the other day. Now, remember a couple of these, the one we did at the top, here's where you just picked the 5 words. You just picked whatever 5 words you wanted. And remember what we saw, we eventually decided this was a very biased method because almost all of you ended up picking a sample of words that was above the blue line of truth. So that was biased. Now, when we brought the random number generator into it and said, randomly get your 5 words, then we got this dot plot. Now, you guys haven't seen these dot plots yet because these have 5th period students that are piled on top of your results already. So this is kind of like the ending picture here for our samples. But this one is unbiased because if you look again, about half of you got a sample that was less than the truth of 4.26, and about half of us got samples that had an average that was more than the truth of 4.26. That's what unbiased means. About half are below and about half are above. Half the time above, half the time below. And so what we're going to look at next is what happens when you take samples of 10 words. Now, period number 1 only had 10 students total in it. So we don't have too many dots down here, but when we start throwing yours in, we're going to see, hopefully, more of what we expect to see. So I'm starting at the top. Here comes Dawson was 3.6. When I hit enter, Dawson, you're going to pop in somewhere right in there. All right, there you were right there. Okay, but let's keep going. Caleb was 3.4. Julia was 5.8. So Julia is going to be over here somewhere. There she is. Eli, I'm skipping over your 0.7. Maybe I don't see the rest of the chat. You might have fixed it down lower. Elliot was 3.8. Eli was 4.7. Now I got to scroll through my chat here. Trevor was a 5. Trevor, were you exact? It was exactly 5, or did you round it down to 5?
It was exactly 5.
Okay, 5 it is. There's 5. Tegan was 3.7. Jocelyn was 4.4. Michaela was 4.1. Jack was 3.5. I got to scroll down to see the rest of them again here. Noah is 3. Where'd Noah go? 4.3. Hold on, got to pull the string of lightness. There we go. Okay, where did I leave off? Noah was 4.3. Here comes Eli, 4.7. Rachel, 7.1 with a question mark. What's your question mark mean, Rachel?
Everyone else had a lower number, and I didn't know why mine was so high.
Well, but you did it randomly. I mean, yeah. You popped out 10 random numbers?
Yeah.
Okay, well, we'll take it. Ethan was 4.9. Josh, 3.8. Sydney, 6. Sydney, you're 6 exactly?
Yeah.
Or did you round it? I'm sorry, I didn't hear.
Exactly 6.
It was? Okay. All right, we'll take it. Okay, and yours is the last one. Okay. So what are we supposed to see out of this? You guys can see the dot plot down here. Now, question number 4 on your worksheet is asking you to make a quick copy of this dot plot now, the one where we have our 10-word samples. So take a quick minute and rough sketch that in there again, and throw that blue line of truth in there as well. This is looking a little better compared to when it was only period number 1 students in there, because you guys just gave us whatever, almost 20 more dots to throw onto it. So what are we seeing? Well, as you guys are copying it down, roughly copying it, here's some things I see. It does look like roughly half are below and roughly half are above. Okay, roughly. I'm sure if we counted it, it wouldn't be exactly the same numbers there, but it seems somewhat close at least. Okay. Now, the other thing that we want to see, and I'm not sure I don't think we're seeing this really, really well when there's only first and second period dots in here. So I'm probably going to have to show this to you again on Monday and Tuesday after we get fifth period's results in there. But the big idea we're trying to see is this. And this is kind of what question number 5 is asking about. In fact, I'm going to go back to our slide and start to address this here. Okay. So question number 5, what happens when we increase the sample size? I'm going to talk about it and we're going to go back and look at the picture. Okay. We have this idea. This is big idea number 2 called sampling variability. Sampling variability just means this. Every sample is different. Okay. Rachel got a 7.1. Sydney got a 6. Josh got a 3.8. Noah got a 4.3. Okay. Every sample is different. And some of your samples were below the mean. They were below the blue line of truth. And some of yours were above. Okay. That's not surprise at all. Sometimes we get below it. Sometimes we get above it and we take the sample. Now, what should happen is this. What should happen, and I think we'll see this better once fifth period's dots get in there, is that when we increase the sample size, when we go from 5 words at a time up to 10 words in your sample like you just did, what we should see is this. What we should see is that how far apart your dots are from each other should start to decrease. All of your dots should start to get closer and closer so that they're centered closer around that blue line of truth, okay? The true average 4.26 of all of the words in the Gettysburg Address. So if I could summarize that, here's the basic idea. When you increase the sample size, you're going to decrease this idea called sampling variability. Decreasing sampling variability means the dots are going to be closer together. They are not going to be spread out from each other as much as they were. And we'll go back to our dot plots to help you kind of see the picture of this. But you take bigger and bigger samples, not 5 words, but 10 words, not 10 words, but 20 words. If you took bigger samples, our results should start to get closer and closer to each other and get closer to that truth. Let's go back and take a quick look at the picture of it. Okay, so we want to compare these two, 5 words at a time versus 10 words at a time. Both of them look like they're centered roughly around that true blue average line. What we should see, and it's not real apparent, I'll tell you that right now, it's not as obvious as I was hoping it would be, is that the dots down here, when we take 10 words at a time, they should be closer in with that blue line, closer to that blue line than what we're seeing up here when we took 5 words at a time. And I think they're sort of doing that. Like, I mean, we got a lot of words out here, or a lot of samples that are in the 3 range. We don't have many right in here, not as many. These samples up here had some outliers. We got Rachel with the question mark out there at 7.1, but we haven't had anybody as far away as the 8 here. We'll see what it looks like after fifth period gets into it, okay? But big idea is this. You increase the sample size, you're going to decrease the sampling variability. Just picture it. They're going to get closer into that truth, okay? That is big idea number 2. All right, so let's do an example here like this. Have you guys ever driven out by Southeast Polk High School? And if you go past Southeast Polk High School, you have the Metro waste dump that is the huge landfill. Have you guys ever seen that? Anybody seen it? Or does your garbage just magically disappear every Friday or every Tuesday or whatever day it gets picked up? Okay, just so you know, all of our garbage in Ankeny goes out about a mile past Southeast Polk High School. Every day it gets driven out there, and they dump it into an enormous landfill that's out there. You can see it from the highway that goes right by it if you look for it. But here's the idea in this problem. Eventually, landfills run out of room. They can't fill in anymore, and so sometimes what they do is they convert them into parks. So they take a landfill, big, ugly mess of landfill trash down here, and they turn it into just green space with trees and grass. And so the question is this. Does the presence of a landfill, if you have all that trash underneath your park, does it affect the trees that grow in the park? You know, I mean, that seems like a pretty obvious question. People might wonder, does having trash underneath the dirt, does that affect how well the trees grow maybe? So imagine this, we got a park that is built on top of a landfill. There's 283 trees in the park, and researchers want to closely inspect a sample of 20 trees. They want to get 20 trees to look at. They don't want to look at all 283. So the question is asking us, how could we get a simple random sample of 20 trees using a random number generator? So notice it's not saying do it with a hat. It's saying do it with the random number generator. So if I was going to do that, I would use, I'm going to go back here to our idea about what we did before. Okay, think about how I would switch this up. I would have to give, instead of giving every word a number, I'd have to give every tree a number. And my numbers would not go from 1 to 268. They would go from 1 to 283. Okay, so the process would be nearly identical. I would use a random number generator to select not 5, but we'd get 20 different trees. And then we would use those 20 trees as our sample. So once we identified them, tree number 17, tree number 196, tree number 74, and then we get all of our 20 trees, then our tree researchers, whoever they are, would go out and look at every tree, inspect them, check them, whatever they're going to be looking for, who knows, and that would be their 20 trees in the sample, okay? So hopefully looking at this, you see that the process we talked about, whether you're picking words or picking trees or picking 50 centennial students, it would be the exact same idea, okay? If I wanted to get a sample of 50 students, I could do this. I could give every student a number from 1 to, make a guess. How many centennial students do we have? You guys know ballpark? Give me a ballpark. Dawson, what's the ballpark number of students in our school?
500? I don't know.
500 would be a pretty low ballpark. We're going to be a little more than that. Anybody else got a shot at it? I don't know the exact number, but I know roughly what it is.
800.
I heard 800. That's a pretty low ballpark too.
1,500.
1,300.
I'm hearing
2,000.
1,300, 1,500. Those are much closer. I think we are pretty close to 1,500 students in our school. I think it's pretty close to that. And it's getting bigger every year. That's why we got the addition going on. But I could use a random number generator, and I could spit out, if I give every one of you students a number from 1 to 1,500, I could get 50 different students, and I could use those 50 students as my sample and say, what do you think about returning to hybrid learning? And I could use you 50 students to be my sample to sort of represent the entire population of all 1,500 centennial students. Okay, so here's our final definition. We've been talking about this word, a simple random sample. What is a simple random sample? We've talked about how to get one, but what is it? Here's our definition. A simple random sample is just a sample where this happens. You choose your sample in some way, whether you use a random number generator, whether you use slips of paper and a hat, doesn't matter, but you choose it in some way so that every member of the population has an equal chance of being selected. So if I'm choosing 50 students, you have just as likely of a chance to be picked as any other student who goes to Centennial. Okay, no student is more likely to be picked, no student is less likely to be picked. Everybody's got an equal chance. Every tree in that park has an equal chance of being selected. Every word on the Gettysburg Address has an equal chance of being selected. Okay, that's a simple random sample. So this is the most common way that statisticians take a sample. Simple random sample is by far the most common way we do it. But it's not the only way. There are other ways we do it that kind of tweak this a little bit, but that's the most common method, okay? All right, what are we thinking here, people? Any questions you guys have? I don't see anything in the chat. Is there any questions you guys have about what we are doing today with our big ideas about simple random samples? Anything we are thinking?
How many Centennial students are there? I lagged out.
I don't know exactly, but it's roughly 1,500. Okay. About 1,500 students at ACHS. But that's about 300 or 400 more than when we started at Centennial 8 years ago, I think we started. So it's growing every year. Okay. Then here's how we're going to finish up. What you guys need to do on the back of the activity 3.3, there's an application question titled, "Do you tweet?" about students using Twitter. So I want you to work through that. And you're going to be talking about, like I see the very first question, how could you select a simple random sample of 50 students using a random number generator? I think we covered that. So I think you guys know how to do that. I am going to jump back to our week 15 objectives. So take a quick look at this with me. We are down here on Thursday, so we just had our live class. So what you guys should be doing to wrap up today's work is I want you to tackle homework 3.3. There are 3 problems on it, and you can always check the answers. They're down in the red homework packet link down here, so you can check them. And as always, I want you to take 10, 15 seconds, fill out that daily progress form, just to say, here's my name, here's what I got done today for Prob and Stats. For tomorrow, your last day of online learning, at least for the time being, who knows if we'll go back to it. For tomorrow, what I want you to tackle is this. Make sure you've done the homework and you've checked it. I want you to complete the lesson 3.2 exit ticket. Some of you have done this, but there's a good number of you that have not. The link is right there to show you what it looks like. Here's what it is when you get into it. This is a question about a restaurant manager getting reviews on the Yelp website, and it's going to ask you about the idea of bias and the results they're getting. Are they biased, and how you can avoid the bias? Okay. And then even though you guys are coming back to school next week, Monday and Tuesday, I do want you to do this. I want you to look ahead to the lesson 3.4 slides, and those will be posted on Classroom. And I want you to go ahead and just try and take care of those definitions, getting them written onto your notes page. You do have a 3.4 notes page. It'll just help us to go a little bit quicker when we're working that activity next week. Okay. All right. Otherwise, questions you guys have, any thoughts, any thinking, any concerns? Caleb, what are your concerns?
I don't have any concerns.
Caleb says he's got no concerns. Okay. Anybody with any thoughts or ideas? Any questions about the hybrid going back here to it next week? Make sure you still remember what group you are in. Group 1 people, you're coming on Monday. Group 2's coming on Tuesday. Just so you guys know, Group 1, you are also Wednesday. Okay, so next week, Group 1 is the Wednesday group coming to school. All right. Okay. Otherwise, our class goes till 10 o'clock. We got just a handful of minutes left. We are done with our activity. If anybody wants to stick around, I'll stay on here till 10. If you got any homework questions or anything you want to ask about, I'm happy to do so. Otherwise, I will see you Monday and Tuesday in class. See you then. Bye, everybody. Dawson, I still see you're still there. Any questions you got?